All right, peeps. In this video, we're actually going to go backwards with linear inequalities. I've given you a graph that's already been, well, drawn out for a linear inequality, and you're to go backwards and find the inequality that matches this graph. So the instructions say, write the inequality represented in the graph. On the flip side of this video, I'll do one other one. It'll be pretty sweet. Okay, so how do we do this going backwards? Well, the easiest thing to do is actually to first figure out what your boundary is. In other words, let's find the equation of this line, ignoring the fact that there's an inequality and some shading going on. So this line has a y-intercept at -1. So I'm basically going to write out y equals mx plus b. That's my goal. That's what I'm holding in my brain. And I know that b is -1. Then I need to know what my slope is. So I'm going to get y equals something times x, and that's going to be my slope. So what is that something? Well, let's find the slope. We would go up 1, 2, 3 over 1, 2, 3, 4, 5. So you make that little triangle mentally like so. You get up 1, 2, 3 over 1, 2, 3, 4, 5, which would be a rise of 3 and a run of 5. Now, if you're having trouble with that, go back to my earlier chapter, right, in chapter 6, where I am rocking and rolling, and you're rocking and rolling with how to write equations of lines. That would be a good place to start if this is giving you trouble. Y equals 3/5 x minus 1. Well, it's not equal to, it's a dotted line, and we shaded above it. So if we're doing everything greater than, right, greater than that boundary, then all the y values are above it. It would be y is greater than, it's dotted, so no or equal to 3/5 x minus 1. That's it. You can do a test point to make sure that's right. Again, 0, 0 is a good point to check. So if I plug 0, 0 into this, I get 0 is greater than 3/5 times 0, plugging in x and y, minus 1. And we get 0 is greater than -1, which is a true statement. So 0, 0 is in the shaded region, so we're correct with the direction of our inequality sign. I'll see you on the flip side where I'm going to do one more of these kinds of problems. It might involve a vertical or a horizontal line. Ooh, see you then. And here we are on the flip side of the video where, as promised, I gave you a vertical line with the shading to the left of it. And we're going to create the inequality that is represented by this graph, essentially going backwards here with linear inequalities. It says, write the inequality represented by the graph. Well, first things first, like we did in the beginning of the video with our other line, we're going to come up with the equation of this boundary. It is a vertical line, which means that it is going to be some form of x equals a number. So the boundary is x equals, and let's see where we are, 1, 2, 3, 4, 5, 6. So it's x equals 6. If you're having trouble with coming up with that boundary line, go back to chapter 6 in the Algebra 1 course and check out vertical and horizontal lines. You'll understand where I'm getting this from. So x equals 6 is the boundary. Now, is it less than or equal to or greater than or equal to? Well, these are all the x values to the left of x equals 6, or, well, less than it. There you go. So it's going to be x is less than 6. But we notice that the boundary includes all the values on 6. So it's shaded in. It's a solid line. So it's going to be less than or equal to 6. We'll use our test point of 0, 0. But we can really only plug in for x, and true to form, 0 is indeed less than or equal to 6. So 0, 0, which is in the shaded region, is correct with our inequality, which means we picked the correct direction for our inequality sign. That's it, peeps. X is less than or equal to 6 is our answer, as it were. See you next time.